In these problems, we're talking about direct and inverse variation. The formula for direct variation, the general formula, is y equals kx. And the way you would translate that from a word problem is y varies directly with x. So the thing that's varying is over here. The thing that it varies with is over here multiplied by a constant k. And the way these problems work is typically you're given an x and a y, you solve for k, and then you use that when you're given another y or x to solve for the other one. Let me show you how that works in this first one. It says the amount a spring will stretch, S, varies directly with the force. So just to translate that into our general form here, the length of the stretch varies directly with force. Okay? And then it says, if a spring stretches 8.4 inches with 60 pounds attached, how far will it stretch with 90 pounds attached? So there's two parts there. First, we're given both the S and the F, and we can use that to solve for K. And then we'll plug the 90 back in when we've got K. So let's do this first part. The stretch is 8.4 inches, and it has 60 pounds attached. So to solve for K here, all we have to do is divide both sides by 60. And 8.4 divided by 60 looks like K is 0.14. And now we'll use K in the second part. It says, how far will it stretch with 90 pounds attached? So I'll go back to my original equation here, S equals KF. And they're asking how far it'll stretch, so I don't know S. I'll put it over here. But I do know K, it's 0.14. And we're going to multiply that by 90 because we're putting the 90 in for F. So 0.14 times 90, that is 12.6. And this was in inches. So that is our answer. And I do like to look back and ask myself, does this make sense? In the first part of the problem, a spring stretched a little over 8 inches when 60 pounds were attached. Then it stretches 12 inches when 90 pounds are attached. It stretches more with more weight. That seems to make sense. So I think I'm on the right track here. Let's look at another one. This one is also a direct variation, but it's a little bit different because it's a direct variation squared. And you'll see this a lot with problems about gravity, how fast things fall or how long it takes things to fall. This one says, on planet X, an object falls 13 feet in 2 seconds. Knowing that the distance it falls varies directly with the square of the time, and there is our formula. How long does it take an object to fall 66 feet? They want us to round to 3 decimal places. So let me write the formula first. Distance varies directly, so there's my K, with the square of the time. So instead of K times T, it'll be K times T squared. And that's our formula. And then we're given 13 feet in 2 seconds, so we can plug those in here and solve for K. So 13 equals K times 2 squared. So that would be 13 equals K times 4. We can divide by 4, and we get K equals 3.25. Okay, now we can go to the second part of the question. It says, how long does it take an object to fall 66 feet? So that's the distance. So we're going to plug that in for D. So 66 equals, and we have our K, it's 3.25 times T squared. So to solve for T, we need to divide both sides by 3.25. 66 divided by 3.25, and I get T squared equals 20.30769. And we're going to take now the square root because we have T squared here and we're solving for T. So we'll take the square root of both sides. And we'll ignore the negative answer because negative time doesn't really make sense. And when I do that, I get T equals 4.5, and they want 3 decimal places, so 506, and that is seconds. So that's a direct variation squared problem. Let's do another one. All right, this one says if x varies inversely as the square of y, and x is 1/16 when y is 8, find x when y is 3. So inverse variation is a little bit different. If you say y varies inversely with x, it would look like this. Instead of k times x, it's k over x. Now this problem is a little bit confusing maybe because they're switching the place of x and y. Instead of y varying inversely with x, they're saying x varies inversely with the square of y. And that's okay. It doesn't really matter. All these letters are just placeholders. So let's write it the way it's written here. X varies inversely with the square of y, so that'll be y squared there. And now we can start plugging in the numbers here. So we're given x is 1/16 when y is 8. So let's plug those in. 1/16 and y is 8. That has to be squared. So that is 1/16 equals k over 64. And I think I'll just cross multiply here. And I get 16k equals 64. And then I divide by 16. And I get k equals 4. So that was pretty simple. Now it says find x when y is 3. So we'll go back up to our original equation here. And y is 3. We'll plug that in. So we're looking for x. We found k. It's 4. And we have 3 squared under here. So x equals 4/9. And I think I'll just leave it like that rather than converting to a decimal. So that is a little bit about direct and inverse variation.